Hello, statisticians. In this lesson, we are learning about informed consent and natural experiments. Let's get started. To dive into these topics, we're going to explore whether college is a good choice for everyone. You may have heard the messaging that you need to be ready for college. Your parents may have said it, your teachers and counselors may have said it, the recruiters certainly have said it. But let's look at it from a statistical lens. Let's start off with two facts about college in the United States. Fact number one, on average, college graduates make a lot more money than high school graduates, about $30,000 more per year as of 2018. That piles up over time. Fact number two, despite the rising costs of college, the average economic return on investment to a college degree is still higher than stocks, bonds, and homes. So, is this college effect a correlation or a causation? Some think it's causal, that going to college directly causes one to have higher earnings. But are there other possible explanations? For example, maybe students with high motivation and skill are the ones more likely to end up applying to college, and they are also independently ending up with higher paying jobs because of that high motivation and skill level. So, college and those having higher paying jobs tend to correlate. In other words, they happen to coincide. But college may have no direct effect on higher earnings itself. In other words, the people with the highest earning potential are also those that attend college at a higher rate. So, when we talk about students on the margin of going to college, or students on the fence between the motivation level and the qualification level for college, if the college effect is causal, then educators should encourage those marginal students to attend college. But if the college effect is just correlative, then maybe in some cases, educators shouldn't always encourage those students to attend college. There might be certain circumstances that would suggest otherwise. So here's today's question. Does college have a causal impact on wages? With that question in mind, let's move on to our notes. Today we're talking about two topics. We'll start with ethics of informed consent. We've talked about privacy, especially data privacy, but even after we have considered privacy in conducting an experiment, that doesn't mean we can just start experimenting on people. They have to agree and they have to know what they're agreeing to. That leads us to consider informed consent. The definition of informed consent has a lot of components. If it's an ethical and legal process, and that means that there are laws about it, and it essentially becomes a legal contract between the researcher and a study participant. In this process, the participant has to be a competent individual. That means that they are capable of making the decision. For research purposes, a 3-year-old, for example, is not competent to give informed consent because they might not be able to understand all of the details or implications of participating in the experiment. If the participant is competent, then they agree to whatever the study includes after they are given all the information about it, including risks, and they get to ask questions and make sure they understand it. This agreement has to be voluntary. They can't be pushed or bullied into giving consent. This informed consent is crucial so that participants have the right to decide not to participate or to be surprised about something in the process. Informed consent has two parts: the information that has to be shared with the possible participant and their agreement, which is called the certificate of consent. You've probably given some form of consent many times, especially every time that you accept terms for an app, a game, or a group membership. The many pages that you scroll through or skip altogether are the informational part of the agreement, and your signature is the consent. Sometimes just checking a box is judged to be consent. But What we focus on is information in the informed consent research. All of these things are part of the information a researcher has to provide. Pause here for a minute or two to read this whole list rather than me reading it to you. If you don't know what any of these things mean, bring it up in the activity for this lesson or when you're talking about the discussion question, because you need to know what this information is before you sign on the dotted line for some researcher's study. Once you have all the information for research, then you will sign a statement that looks like this, which verifies that all the steps of the process I outlined before have been taken. After this video, you'll not only be disclosing our question of the day, but you'll also take a look at some examples of informed consent, what will look like in reality. Now, let's look at a specific example of what an experiment with human participants might look like. In the statistical world, one way to do this is with a natural experiment. Let me emphasize this. Experiments have to start by making sure participants' privacy is protected, that they know what the experiment is about, and that they agree to be part of it. We started today with a question about whether college causes higher income. To infer causation, we need to do an experiment. We could gather a bunch of students on the margin about college, randomly assign them to two groups, where one group goes to college and the other doesn't. Then we wait about 15 years and compare their earnings to see if college made a difference. But we can't do that. It's impractical and unethical to try to force people to go to college or force them not to go to college. And who would actually give consent to randomly assign whether or not they can go to college? So instead, we can do a natural experiment. In specific situations, a natural experiment can be used to compare groups that are as good as randomly assigned using observational data. And if it is done well, a natural experiment can give us causal estimation. There are multiple different types of natural experiments. The one we're going to focus on today is called regression discontinuity. This method uses an arbitrary cutoff to compare those as good as randomly assigned groups. To make this more clear, let's look at an example. This study was done at a Florida college by economists at Yale to explore whether college has a crucial impact on earnings. This was a published study, but we'll look at a modified version. While Zimmerman used multiple regression, this is pretty high-level stuff, way beyond what you're expected to do in this course. So instead, we're going to modify the data to behave similarly and get similar outcomes. At Florida State in the early 2000s, they had a GPA cutoff for admission. The magic number was 3.0. If you had a 3.0 or higher, you qualified for admission to the university. If you had anything less than a 3.0, you got the "we're sorry" letter because you were not admitted. The study compared earnings for students in high school who were just near the cutoff, so just slightly higher than 3.0 and just slightly lower than 3.0. For the method of the study, they made the key assumption that students close to the cutoff on either side were as good as randomly assigned for placement. And they made additional checks on that assumption. First, they made sure that the students on each side of the cutoff were similar in their characteristics. So similar groups in both sides for gender, so equal numbers in each gender. Similar races in each group, similar income levels in each group, similar application rates in each group. Later in the study, they checked to make sure that their participation in the workforce was also similar. Then they also checked to see that the students and teachers had not done anything to change the GPAs to squeak by to make the 3.0 cutoff. And that evidence came directly from Zimmerman's research. With all this in place, here's what they found. They looked at the mean income and the standard deviation for that income in both the college group and the high school only group. 8 to 14 years after high school. Remember that the college group had a GPA of 3.0 or just a little bit above, and the high school group's GPA was just a tiny bit under 3.0, and the groups were pretty close in size. If college made a difference for students on the margin, just above or below the cutoff, students above the 3.0 mark should have a slightly higher average income than those below the cutoff. So let's consider the mean incomes of the two groups. To see if the mean income of the college group is higher than the mean income of the high school group. The college group did have a higher mean income, almost $7,000 higher per year. And the researchers found that this result was statistically significant, meaning that it was so large that it was unlikely to happen by chance alone. Because this was a natural experiment in which we compared students just above and below an arbitrary cutoff, meaning that the students were as good as randomly assigned to the college or not, we can say that the college caused the boost in wages. So that raises our discussion question for today. Many colleges have tried to recruit more students from underrepresented backgrounds, such as students from color or low-income students. One problem, because students from these backgrounds are disproportionately attending lower performing schools, many have lower GPAs or academic qualifications. Because they come in feeling behind, they may have a difficult time catching up. Colleges worry about underqualifying students, and they worry that they might have bad outcomes, like not graduating or taking on more student debt. To help recruit students from a wider variety of backgrounds, universities in Florida are considering lowering their admissions standard for high school GPAs. So that brings us to our discussion question for today. In your view, would this be a wise move? Explain your answer using the Florida College Study results. Take a moment to jot down your initial thoughts to this question and discuss them further with a classmate. Be ready to share your answers. That's it for today, statisticians. We'll see you next time.